Hi, in this tutorial we'll talk about optimization techniques we can employ in React in order to make our React apps faster and performant. So I've got a bunch of sections here which I will talk about, and then we'll individually see what each particular thing can be, how it can be used to enhance our experience and optimize our React apps. So first of all is lazy loading components. We know that in case of React, if we have an app with several components and pages, then at the time of website loading, the whole bundle of components and pages, whatever that is, the whole app comes from the server to the client, so that we can get a single page experience, and we can load the components quickly, etc. But that is also makes the website slow because the initial load time is a lot. But there would be some components which you wouldn't normally use. Let's say there's a part of the application which users don't really go to, so you would want that at least those parts of the application only be sent from the server when they are needed. So you would want that when that component is shown, then at that particular moment it is fetched from the server and not at the initial when the website is initially loading. So that is when you use lazy loading. So right now you can see that there are a bunch of things which have been fetched from the server for this particular component. But we can see that if I go to this particular component, where it is, yep, and this is a component where I'm lazy importing this example component, and this example component is basically saying I'm an example and I will lazy load. And what I'm doing is, when I click this button, I set it to true, and when this is true, then only am I basically using this component. And basically when I would use this component, then it will basically fetch it from the server, and I will show a suspense fallback. So when I click on this button, you can see that after that this example is fetched, this example component is fetched, and you can see a loading indicator as well, which if you see quickly, you can see that there is a loading thing here. So this is an example of lazy loading, and this way your initial load time will be reduced if you lazy load some components which won't be used quite often. Okay, so the next thing is regarding state. So you shouldn't use state for everything. You should only use state for pieces of data which need to be changed based on a certain event. Maybe they need to change based on click, maybe you need to mutate them based on if some other thing changes, or maybe you need to change that based on maybe you're typing something and you want to update the state, etc. Then and then only would you want to use state for your data, not in every case. So in this case, I'm clicking on the button and I'm incrementing the count and setting it to new count variable. Then I have a set squared count setter and a set count setter. So I'm setting the squared value of the new count in this state, and I'm setting the new count value in this state. Now there is literally no need of that, because I could just do this. There was no need of an external state. But what I've seen in new developers is they use state for everything. So what would happen is, because I'm updating the state 2 times, it would cause an unnecessary render. So now the same thing is happening without using state. I could just put this inline. I could make a variable which multiplies it by 2, squares it, or I could use useMemo for it if the computation is very expensive. Otherwise there is no need. So you don't use state for every piece of data. If the particular data you want to display or you want to do anything with it is dependent on state, then you can just use a variable for it or use memo for it if its computation is expensive. You don't need a separate state for it. That is another thing. Now the next thing is fragments. So we know that React can only render one child. So in this case, if this is a component, if I remove div, then this would throw an error. It would say that the JSX expression must have one parent element. So because of that, I added a div. Similarly here, I'm using a map. I wanted to render 2 sentences. I had to basically use a div for that as well, but you don't really need to use div unless you want to use some sort of styling, or I want to assign some data attributes for testing purposes, or some event handlers. If I'm not using those and I'm only using this for the purpose of grouping together, grouping certain tags together, because I have to return only one child, I can just use fragments, and this would basically do one thing. If I look at now again, you can see that there the tree, the HTML tree is very simple. So now whenever we make a state change or do props change, whatever, React would do reconciliation. That is the algorithm which it uses to see what it should re-render and what it should keep as it is, because it hasn't changed. The larger and deeper the tree is, the node tree is, you have divs, and inside that there's another div, inside that there's another div, the more difficult it would be for React to reconcile and see what it needs to re-render, or etc. So if you're only using a div tag for the purpose of grouping children together into making a one child, then you can just use fragments. And if you want to use a key as well, like, you can still use fragment, that would be React fragment, and you can pass a key in this case as well if you are only using the div for assigning a key. So if you just want to assign a key, you can still use fragment, but you have to import it from React, not this syntax, but you don't need to use div for that. Okay, so the next thing is memoization, and that is very important. In some cases it won't do anything good for your components, but in some cases it would improve the performance drastically. In this particular case, not so much, but in most of the cases it will. So consider this: I have a memoization component and I have a state count, and I'm displaying the count. I have a button which increments the count, and then I have this card component. Now I have a console.log here which says card re-render. So every time the card would re-render, this console log would render and we would know. So right now I refresh, I go to console, you can see that the card has re-rendered, obviously the initial render. Now I click on this increment button, it has again re-rendered. I click on increment again, it is re-rendering for no reason. And essentially it shouldn't, because the props are not changing. So if you want that the component doesn't re-render when its props don't change, it should only re-render when the props change, otherwise it shouldn't re-render if the parent is re-rendering. Then you can use React.memo for it. So I would say React.memo, and yep. And now if I refresh it and now I'm clicking on increment, you can see that the count state is updating, but now the card is not re-rendering. Great. Now we can see that this card component has two optional props as well, on click and card content. Let's pass card content to it. I would say card content, it expects an array of strings. I would say comment1, comment2. Now I refresh, now I'm clicking on increment again, and again you can see that the card is re-rendering for no reason, because the props aren't changing. So why is this happening? The reason why this is happening is because I'm using the array inline as a prop, and React.memo would compare the the current props and the previous props, and then basically decide based on that if it wants to render or not, if they are different. In the case of arrays or objects inline, it doesn't actually compare the contents of arrays or objects, it compares the references of that. So obviously whenever it is rendering, the memory reference for this array is changing, so it is reinitializing again and again, and obviously because the reference is changing, the card component is thinking that the content for that particular prop is changing as well, which it isn't. So in this particular case, you can use a useMemo. So I will say card content is equal to useMemo, and it doesn't depend upon a dependency, so there's no need. Let me pass card content. and I refresh and I click on increment. Now you can see that the count is updating, but the card is still not returning. It's great. Now another thing, there is also an optional in on click prop. Let's pass that, let's pass an empty function for now. And again I refresh, again I click on increment, and again the card is returning for no reason, even if the on click function is the same. The reason is still the same. Functions are obviously not compatible, just like arrays and objects. So for the function as well, the card component is basically testing its reference. So it's saying, okay, the reference of this function was this in the first render, now it's changed, so obviously it would re-render. So for functions, we can use useCallback to memoize it. So I will say on click is equal to useCallback. Here, and I would refresh, and now I will click on increment, and you can see that the card the count state is updating, but the card is not rerunning. So these three things, React.memo, useMemo, and useCallback, helped us to basically not make the component re-render without any reason. Now you don't need to overuse it. You only need to use it when your component is very computationally expensive. Maybe it's rendering some rich things, some rich it is re-rendering a table full of table or list full of many items, or it is rendering something that basically makes the process slower, and you only want to re-render that if the props change. So in that case you can do that. Otherwise you don't really need to in this particular case, but because it's literally a div and a UL, a list. But in cases where the component is heavy, you can use these three things to memoize, and it would help a lot in a lot of cases. Not in this particular example, but in a lot of cases it would help you a lot, and it would make your website very performant. Cool. Now the next three things are related to lists in some way. So first is keys. So if I go to keys, so keys are basically identifiers in for any list item in a list, which basically Jack uses to see whenever the list changes, it uses the key to see if which certain items it needs to basically repaint on the DOM. So if there are like 5 items and they have a particular identifier, if I delete one item, Jack would say, okay, that item with the particular identifier is now not in the DOM, and I should only repaint the other ones, or something of the sort. We don't know the exact algorithm, but basically keys are used for that purpose. So keys need to be unique, they need to be identifiable, like they need to be like the an ID of some sort, which remains stable throughout the component lifecycle. If a component remounts, obviously that key can change, otherwise it needs to be unique across the list. And when you talk about unique, obviously it doesn't need to be the same, and it shouldn't be index in most cases, because the list can change. Maybe you can delete an item, maybe you can reorder items, etc. So it shouldn't be the index as well. It should be a unique key, like an ID of some sort, coming from the database, etc. So in this particular case, I have names coming from this constant file, and this is basically I'm using faker.js to make 10,000 names. And basically here I have an input, I set the filter state, this filter state goes here, and I get filter names and I'm mapping them here. Now in this case you can see that I'm using name as a key, which is obviously wrong because name can be similar. And in this case you can see that for a lot of items the key is same. Encounter 2 children with the same key, Clifton Rise, key should be unique. So you would see that it now behaves a little bit weirdly, and same would happen if you use index as keys. So basically anything, keys are basically used for reconciliation, right? So anything you would do with the keys can basically halt or damage the reconciliation process done by React, so it would obviously affect the performance of the app. So in this case, if I go here, right now obviously filter is empty, so filter names length is basically 10,000, which is okay. But now if I type demo, let's say, now we can see that in this particular case it says that the filtered names array has a length of 11, but you can see that it doesn't render 11 items here because filtered names is being mapped here in the list, and it should have only rendered 11 items, but it doesn't. So this is what can happen if you don't use a proper key. Now if I change it to ID and I refresh and I now type demon, then you can see that filter name says 11 items, and now you can see there are 11 items. So whenever you would not follow the key rules, things like these would happen. And obviously you saw in this particular case proper reconciliation or something happened and it didn't render the results properly. Similarly, in cases where you use index as keys, sometimes it wouldn't really matter, and it would really affect the performance, and it would implement the correct result, and you would be like, okay, so this is not behaving weirdly in any way, but it would behave weirdly in some ways and you wouldn't want to do that. So that's one thing. Now the next thing is transition. Okay, so we have another example, almost similar example, but now I am using this value state, which I was already, but instead of using useMemo and deriving the names from that state using useMemo, which I have talked about in the state example as well, I'm using state. The reason for this is, it can be, maybe the list is mutable, maybe the list can be drag and drop, so you would need state for it. So and that is just an example. So basically, let's see what happens. So let's say I type demon. You can see that when I'm typing demon or I'm deleting demon, what happens is that all the state updates are blocking, which means that when I type demon and when I do this, these state updates happen at once. So this state update happens, this state basically filter names basically renders a list on the UI, and whatever is shown in the output, these things happen at the same time, even though setting a string as a state and basically setting a state where I'm filtering an entire array and doing some sort of stuff isn't the same thing. Obviously setting a state, string state, is very simple, it should happen very fast, and basically this list thing can take as much time as it wants based on number of items it has in the list. But obviously the state updates are blocking, they happen at the same time, so that is why this happens, and this is a stuttery behavior and that is not correct. So basically useTransition hook was introduced in React 18, I guess, and basically it helps to declare one of the state updates with less priority. So I can say that this particular state update has high priority, I want it to happen immediately, but this particular state update can take any time it wants. This has low priority. So start transition takes a function. I'll copy this and place it here, and now if I refresh, you will see that the text changes instantaneously and the list follows after that. So I literally cleared demon and you saw that it cleared immediately, but before that wasn't happening. It was the clearing of the input field and the list basically going back to its original shape were happening at the same time, but now it's non-blocking, and because I've said that the list has a low priority, this happens instantaneously, the text state update, but the list takes its sweet time, which it can, I don't mind. And that is basically a good optimized way of doing this, because obviously you would want the text to be displayed instantaneously, but the list can take its time based on the size of the list. obviously in this case there are 10,000 items, maybe there are 100,000 items. Obviously you wouldn't want the text state to appear after like 5 or 6 seconds. That would show that your website is very slow, so you wouldn't want that. Okay, so the next thing is debounce. That is kind of related to list, but it's a general thing. So back to the same example we had with keys, where I have an input, I'm setting the filter, I'm using useMemo to filter the names. So how are you? Yeah, so I go to debounce, I refresh. Okay, so now you can see that obviously this is the first render, the filter names has updated. I typed demon, you can see that filtered names updated was logged 5 times because I'm using a use effect for filter names. So what happened is I typed demon, and obviously demon contains 5 letters, so the state updated 5 times, and state can update 5 times, that's not a problem. But this particular thing was calculated 5 times as well, which was dumb because I typed demon quickly because I wanted the search to be filtered by only demon. I didn't want the search to be first filtered by D, then DA, then DAM, then DAMO, and then demon. So in order to do that, I will use debounce. So basically debounce is a way of making a bulk state update based on the time I give. So in this case I've given it 0.5 seconds. So if a lot of state updates are happening within that particular gap, then they would be basically that state would be kind of updated in a bulk. So in that particular case, this state would obviously work similarly, D, DA, DAM, DAMO, DAMO on, but this would return only demon, which is cool. So I can then basically filter based on this debounce value and not the original state. And now if I refresh, original initial update happened, it's okay. Now if I type demon, you can see that only one update happened, and also the text update happened smoothly, which is pretty cool. So debounce is a way of basically delaying the state updates and basically making a bulk update for several state updates, which is pretty cool, and you should do it in order to optimize your workflows, which you saw in this case, and it was pretty good. So last thing, there are other things as well, but last example is virtualization. So yeah, so in this particular case I'm rendering 500,000. I'm rendering 10,000 items right now, but let me change it to 500,000. So 500,000. Let me open another tab, let me close it, and let me open it, and now you will see that it would act very slowly because I'm rendering 500,000 items on the screen. And obviously you can see that it is literally taking time to load. Now it has loaded, but the context menu is taking time, then spec tools would take its time. Basically the website is stuttery. The scroll bar hasn't even appeared yet, which it should, but it hasn't. So yeah, now it has appeared, and even if I've scrolled down, it isn't scrolling. Basically the website has hanged because it has rendered 500,000 items on the list. So you wouldn't want to implement a list like this in this case, because you don't really know. You are obviously fetching the names or any data from the database, and the database can have any amount of data. It can have 1,000,000 items, it can have 1,000,000,000 items, you don't know. And if you render it like that, it would basically, the website would basically hang on you. So in this case it hanged, it crashed. So in this particular case you would want to use virtualization. So now I do this, I refresh, and you can see that it has rendered. These are still 500,000 items, but everything is smooth, everything is working. Virtualization is basically a process in which you specify a viewport height, in this case 800 pixels, you can see here, 700 pixels, and I would say that I only want to render the items in this particular viewport. So in this particular box, I want to render only these items on the screen, and as I scroll, I want to show all the other items. If I can show you here, yeah, so now you can see that they are literally changing as I scroll, and it is rendering only some items, I guess like 20, not 500,000. So based on the position, scroll position I have, it would change the items it is rendering on the screen, and that is a very performant way to do it. And yeah, and that is the industry standard of making displaying lists. And you can use libraries like React Window, React Virtualize to do this. Now all the examples are finished. Server-side rendering. So React has a lot of upgrades in terms of Next.js and some other frameworks, and Next.js is by far the best one because it has optimized React in a lot of ways. So because it is a server-side render framework, and it basically bundles pages and fetches pages based on the route you have, it has a faster load time. It doesn't bundle the whole app in one bundle and fetch it all at once. So obviously that optimizes the website. Then indexing and search engines, obviously because it is server-side rendered, everything is rendered on the fly on the server, and the page comes, and when the page comes on the client, it is already rendered HTML, etc., everything. So it has better indexing. Then also improve performance, because obviously because of bundling, if you have a low-end device like a computer with a very less RAM, etc., so it would the website would work really well there. And also it's more secure because everything works on the authentication and all the other stuff is handled on the server. Then some miscellaneous things which we can use. So this is pretty obvious, because obviously if you want to deploy a website, you would want to deploy the production build, but still, because React says it in its docs, I thought I should tell. Production build is much faster and much more performant than the dev build, so you should always use it. Then use a better bundler. Webpack is very old, and now most of the devs don't use Webpack, but if you use Create React app, then it comes with Webpack, and the React app is very slow. So if you're developing, you would see that every small change takes a lot of time to reflect on the screen, and it's not an optimized way to do it. So you would want a better bundler. Right now Vite is a very good bundler, and I'm using Vite right now as well, but TurboPack and these new bundlers are coming which are even faster than the previous ones. But don't use Webpack. Try to update your bundler. And then React Profiler is basically a thing which comes with the React Dev tools in your browser, and that can be used to see and investigate how much time it is taking for your component to render, and then based on that you can basically do certain experiments. You can delete a component, you can early return a component, and you can do several things in order to see if the component is now behaving in a faster way or not. If it is, then you can know that this thing is slowing my website, and then you can delete it, or you make particular changes. So this is an official way to see. Obviously you should do these things by default, but if the website is still slow, you can use React Profiler to see what is making it slow. So this was the tutorial for React Optimization 101. I'm sure you like it. If you liked it, then comment down below and subscribe to the channel. That helps a lot. And if you have any requests for further React or anything, you can also comment down below. As always, like and subscribe, and I'll see you in the next video. Bye.